Alright, so this lesson we're going to learn to complete the square. We're trying to solve a quadratic equation, and rather than just factor, sometimes we can't factor, so we can try this method, completing the square. And it works on just about any quadratic. Just about. Alright, so as warm up, let's try this exercise. Rather than taking this 35 over to that side, just look at the trinomial that's on the left. And maybe you recognize that this is a perfect square trinomial because half of this number is 5, and 5 squared gives us the 25. So this is a perfect square trinomial. So it factors as x minus 5 quantity squared equals 35. And now let's just take the square root of both sides. X minus 5 equals plus or minus the square root of 35. That doesn't simplify because 35 just has 5 and 7 in it, and none of those are perfect squares. So then just add the x over. So 5 plus or minus square root 35. And there's the answer. So I do want to point out something about this, and that is that these things are conjugates. But the thing about this problem is that not every single quadratic is going to give you a perfect square on one side, so that you can just take the square root of both sides. So that's what we're going to learn to do here. So not every single trinomial is a perfect square trinomial. However, we could trick it into becoming one by completing the square. So to learn how to do this, we're going to do some algebra tiles. Now usually I think algebra tiles are pretty useless, but this activity is pretty okay. So on my website, if you wanted to cut out those algebra tiles, cut out some nice pretty ones, and let me go back here for a second, just talk about what algebra tiles are. So the big square, that represents x squared. Think of it like the area. This is x times x gives us x squared. The long rectangles represent just the variable x. It's like 1 times x for the area of x. And then finally the little tiny squares are the number 1. 1 times 1 gives us 1. So cut them out, and let's use the tiles to represent x squared plus 6, which means we need one big square, and then we need 6 rectangles, long rectangles. Now, what you want to do is you want to turn this shape into a square. Obviously, if you just line them up, you're just going to get a rectangle, but we want it to be a perfect square. That's what completing the square means. So you have to use these and arrange them some kind of way within this square, but then you're going to have to add some of those little tiny unit squares, some of these things. So I'm going to give you a second. Go ahead and pause the video, cut out your tiles, and see if you can do it. Alright, so hopefully you accomplished it. If you didn't, just take a look at this example. So to create the square, what you're going to do, of course, is set up your big x squared. Now take half of your x's and put them on one side of your square. Take the other half and put it on the other side of the square. So here I've got 3 of the x's on one side. I've got 3 of the x's. And here I've got the other 3, just splitting those in half. And now I have to fill in this gap right here with those little unit squares. How many of them there are going to be? There's going to be a 3 times 3, which is 9. So 9 is the number that we need to complete the square. So notice that whenever you go to complete the square, you're taking half of this middle number, which is 3, and then you're squaring it to get 9. This is what we mean by completing the square. The number 9 is the number that we have to add to the original binomial in order to complete the square.